let's try and create something like a AI login tool with AI. First, we're going to use Miro to develop the concept. So if we say we want an AI logging tool which organizes by priority. So we've seen it before where we use journal CTL and the P tag, which gives us the priority listing. So this will be the priority from whether it's an emergency, a regular alert, or just basic system stuff. So with this, we're going to see if it will create us some form of architecture. So we can go through here with the sidekick, and that will then give us a bit of information. So so now we're going to ask it for a chart. So is this organized in a structured flow chart for us to continue in our development? Excuse my spelling because I can't seem to spell. So instead of creating what seems to be a random output, we're going to ask it for a flowchart. So now it looks like it's using something called Canvas. So it's visualizing it for us to visualize on Canvas. So the stages it's going through by the looks of it, let's just zoom in. We go from the start, ingest log, and then we can classify the type, and then it will give us the type by our priority. So in this case, it's an error, a warning, info, debug, etc. And then it will go through the routing type and decide how we should handle this piece of traffic. So based on its listing, it's giving us either a high priority, a medium priority, or a low priority. So this is the piping system in which it wants to go through. So we can go down further. If it's a alert, we can give an immediate alert, a queue for review, or a standing log. Now this is quite interesting because this is how a security information and event management system would record these sorts of logs. It will go through based on priority. So we can see whether we want to escalate the issue. So maybe we were having a backdoor and we'd found someone trying to log into one of our accounts or our SSH. Then we would escalate the alert, or we can monitor the log or go through periodic review. And then assign status and some random stuff here, which seems a little bit close for comfort. Store or resolve the log. So what we can do with this is we can copy as an image, go into our Visual Studio Code, and then we can prompt it on here. So we can say something like, we've got a flowchart based on our results for logging a journal CTL. And then we can paste that image in there, so it now has access to the flowchart. And this is a pretty good tool for just creating a workflow, seeing how a system actually... So instead of actually going in and creating something, you can kind of visualize it first, create a system, check that system, and then it'll go through. You can see if you have your login as verbose. You can say the user wants to create a design based on the flowchart they've shared. The flowchart shows a log analysis, systems with the workflow, start, ingest, log, classify log type. Okay. Sounds interesting. So all paths serve at monitor log, assign status, diamond, decision, active, resolve, investigate, store, resolve, parallelogram. So I need to build a Python-based implementation of this journal CTL log analysis automation system that ingests logs, classifies them, assigns them by priorities, routes them through different handlers based on severity, and manages their life cycle through monitoring and resolution states. So you can see now here we've got the ingester. So it's going through these now and actually creating a Python script based on the flowchart that we've created and how they will react with each other. We now have the classifier, ingester, and the model, the log types, the class for the log types, for the warning, error, warning, info, or the debug. We've got the classification by its priority, which it states here, whether it be high, medium, or low. And then it goes through the log status, which is either active, investigation, or it's being resolved. And then we have our data classes. So inside the ingester, you can see the syslog priority map, and then some parse entry, how it's parsing the data through the logs, which is some form of normalization of that data. And then it needs to do some form of mixture of experts type architecture, where it will now go through the routing pipeline to identify which logs need to go where based on the rules which we've decided through here. Well, which AI decided. So this will be our main compile models.py classifier by ingester. Okay. So these are how we're actually going to handle the log information based on its priority. We have here, all files compile cleanly. Here's the full project layout. Each file maps directly to a node or lane in your flowchart. So we have the ingest log, which is here, which is the ingester.py. Classify log type, which is the classifier, which we have here. And how we're going to classify this. Assign property, route to handler, we have our routing system, which will be this section here. So if we go to router.py, you can see that the case priority, so handle high entry based on high, these are the case, this is how it's handling it by case, but the entry priority by case. Now let's try and run this bad boy. So we'll just do Python 3 main.py, let that run through, and then we have our logs, which our raw data, which seem to be running through, which doesn't mean that much to me. So with this, we will process the last hour of the journal, which seems to be like this section that we've just done. So we want this to be a little bit more meaningful, so we can just say, so in order to make this absolutely fantastic, by the way, I don't want to get killed by robots, fantastic program, more usable, can we attach a front end? So now that we've got all the logic, we've got the system, we've got the flow chart in which we followed. Now let's attach something which will allow us to visualize this better and understand it in principle, how we would do if we was a SOC analyst, for example. The best approach is a Flask web server that serves a dashboard HTML page, exposes... Ooh, okay, that was gone quick. First, we need to install Flask. So now we're going to run this. It looks like we are running the Python 3 in a separate environment to install the different types of requirements needed for this to run. So we're now setting up the Flask app with SSE infrastructure, designing the HTML dashboard with a professional dark color, just how we like it. We love a professional dark color. Flask 3.1.3 is ready in the virtual environment. Let me plan and build for things together. The Flask app server, the HTML dashboard template, a static CSS file, and a requirement file. Okay, so here we have this. Oh, this is all the process logs. Let's get off this page because this is scary. Starting the creation of the dashboard HTML template, which is pretty damn cool. And it's going to make the directory for the automated log analysis here as well. So we have our to-do list. So you can see that it's now created the front end for the Flask app.py, and now it's created the dashboard HTML template, which we can see somewhere here. So now we have our HTML template. We've got our root. We've got our root colors, so this will be the standardization for this program. The body, the background, which is using var-bg, so that'll be black. And then it's going through the navigation, all its keyframes, live label, the buttons. So now it's going to be running at our local host. So what it does is the dashboard features a stats row, so live counts for the high, medium, low priority, and active, investigate, and resolve status, plus review queue depth. So if we go back to here, this then is going through our classification type. It runs through the pipeline panel to kick off a background ingestion batch, configure, unit filter, or file path for offline replay. Live feed tab, SSE powered real-time stream. Every process entry appears instantly with colored priority type status, which is pretty damn cool. So we've now got a refusal to connect to the local host. So the server isn't running, so we can then we can just run our environment. We'll do bin, Python, and then we'll run our app.py. This is development server, do not use it in production deployment. Yeah, yada, yada, yada. And then we can run our local host again. We'll just copy that. And then there you go. We can run our pipeline, get that bad boy started. And there you go. We now have a log analysis tool which was created from the abstraction of Miro into a fully working log analysis tool within like what, 10 minutes. So we can then, if we have a look at this, you can see unit filter optional and Nginx service, the path to the export JSON since last hour. Okay, just like that, we can now see it's analyzed 5,151 logs in total from our journal CTL, the priority. It's found 0 high priority, 615 medium, and 4,536 low priority logs with an active 615 and review queue. So we can then have a look at our review queue. So this then gives us, we should then have a look at some of this information, like is it okay, is it not okay? So these are kernel based errors based by priority. So this is just the power of how quickly it is to create something like a log analysis tool. I mean, we've had an abstract idea, we've managed to come up with the solution. First, going through our pipeline, I mean, we could create this more sophisticatedly if we wanted to. We could get logs from different area types and we could just make this even bigger or production ready. And just like that, we then used Copilot to help us with our development process. And now we have an operational base product.